My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We're here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase it immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 155. Page 155, and today is our lesson number 25. Lesson number 25, and we're going to solve problem number 25. We have 50 people total. We have 50 total people. Problem number 25, we have 50 researchers in a group. 40% will be assigned to team A. So we're going to assign 40% assigned to A. I'm going to start from the little bit to the back. %40 assigned to A, and the remaining 60% will be assigned to team B. But we are told that of the 50 total, we are told that 70% prefer A and 30% prefer B. The question simply is, what is the lowest possible number of researchers who will not be assigned to the team they prefer? In other words, we want to minimize the number of people who are going to be disappointed. Minimize the number of people who are going to be, could be so disappointed or pissed off. Oh, sorry, I didn't say that. Are going to be disappointed. That's disappointed. I don't know how to spell it. I don't know why I put two S's in the disappointed. Unhappy. How about that? Disappointed, unhappy. So here's what's going on. We have a group of 50 people, and we know by survey or must have taken a survey, they must have asked these 50 people, would you prefer to be assigned to team A or would you prefer to be assigned to team B? 70% of the people said they would rather be assigned to the project A because they prefer to work on project A. 30% says we would prefer to work on project B. But it turns out that of the 50 people, we only need 40% to work on project A, and we need as much as 60% to work on project B. The question simply is, how should I arrange my team so that I have the lowest level of disappointment or dissatisfaction, if you like? Because I want a happy group. I want a bunch of happy workers. So I want to minimize the number of workers who are going to be disappointed. Very simple. So what is 40% of 50? Well, we know 40% of 100 is 40. 40% of 100 is 40. Therefore, 40% of 50 must be 20. We know that 60% of 100 is 60. Therefore, 60% of 50 must be 30. 70% of 100 is 70. Therefore, 70% of 50 must be 35. 30% of 100 is 30. Therefore, 30% of 50 must be half of that. So it turns out that 15 of them, 15 people want B. 15 people want B, but we need 30. 15 people want to work on project B, but we need 30 people to work on project B. By definition, 15 are going to be disappointed. That's it. 15 is the lowest number that I can find who are going to be disappointed. Another way to look at the whole thing is to, instead of looking at B, we can look at A. We can look at A and we can say to ourselves that 35, let's put them in a different color or different way. "35 want A. 35 want A, but we only need 20. We only need 20. 35 of them want A, but we only need 20. So by definition, 15 are going to be disappointed. That's all. Either way you look at it. That's the minimum number, of course. The question here is we want to minimize the level of dissatisfaction. Of course, we could actually take, for example, for example, we know that we need 35 people to work on project A. In theory, of course, as a manager, you could take all of these 30 people who said that they would prefer to work on project B, take all of those 30 people and ask them to work on A. But then you will have 30 very pissed off people. Similarly, we know that we need 20 people to work on A, but you get the idea. Oh, we just did that, didn't we? But you get the idea. That's all it is. So we want to minimize the number of people who are going to be disappointed, and the way to do that is this. Absolute minimum is 15 of them want B, 15 people want B, where it go? 15 people wants to work on B, 15 people want to work on B, but we need 30 people altogether. Right here. 15 people wants to work on B, but we need 30, which means the minimum that we're going to disappoint is 15 people. And that's not going to change even if you look at the other way around. Here, if you can look at the other way around, 35 want A, 35 people wants to work on project A, but we only need 20. We only need 20 people, but 35 people prefer to work on A, but we only need 20 people, which means by definition, we're going to have to assign 15 people on project A who really didn't want to be there, but we have no choice. Let's work on the next problem. Okay, enough said. I think I'm explaining too much. Next one. We are told that n is a prime number greater than 3. 26. N is a prime number greater than 3. Question simply is, what is the remainder? What is the remainder when n squared is divided by 12? And the answer choices are, this is number 26. 0, 1, 2, 3, 4, 5. Isn't that very nice? It couldn't possibly be 0, 1, 2, 3, 4, 5 because I just realized that there will be 6 digits, 6 integers. We only have 5 answers. So what are they skipping? They skipped 4. So the answer choices are 0, 1, 2, 3 and then 5. A, B, C, D. So the simplest and the easiest way to tackle this problem is simply to pick a prime number greater than 3. Pick a prime number greater than 3 and divide that number by 12 and see what happens. Let's do it then. Let's use n equal to 5 because 5 is a prime number and is greater than 3. Therefore 5 squared, therefore n squared, which is 5 squared, would be 25. And the question simply is, what is the remainder? What is the remainder when 25 is divided by 12? Well, 25 divided by 12, well, we know that 2 12s are 24. 2 12s are 24, and the remainder is going to be 1. That's it. That's your answer. Very simple, very straightforward. The answer is A. Answer is 1. The answer is letter B. A is 0. That's all it is. Oh, but what happens if we use a different prime number instead of 5? What if we use something else like 11 or 13 or 17 or something like that? My God, what would happen then? Well, nothing would happen then. What you have to understand is that what we have done here is not wrong. Is it wrong? No, this is perfectly fine. Is 5 a prime number? Yes, it is. Is 5 greater than 3? Yes, it is. Is 25 the square of 5? Of course it is. 25 is square of 5. Are we dividing 25 by 12 correctly? Of course we are. So this answer is correct, which means it cannot change. Answer cannot change just because you're using a different prime numbers. You cannot have more than one right answer. If you were, in other words, what I'm trying to point out and make you understand is that if you were to use a different prime number other than 5, it couldn't possibly give you a different answer because you cannot have more than one right answer. To convince you, we're going to do a couple of them. Let's do a couple of them. But answer couldn't possibly change. Let's try 7, shall we? Let's try 7. Let's use n equal to 7. So n squared would be 49. 49 divided by 12 would be 4. 4 12s are 48. And the remainder 1. What do you know? Let's use one more if you like. We use 5, we use 7, we can use 9, 5, 7, we can use 9, let's use 11. 11 is a prime number, let's use 11. 11 squared is 121. What do you suppose would happen if we divide 121 by 12? Well, it will do 10 12s are 120 with the remainder of 1. Then you can sit there and try all you want. You can try as many prime numbers as you want. One of the properties of prime numbers, which is a very obscure and what's the word I'm looking for? Not widely known property of a prime number is that when you square it and divide it by 12, as long as that prime number is anything greater than 3, can be 2 and can be 3. As long as it's more than 3, as long as it's a prime number and not a 2 or a 3, then if you were to square it and divide by 12, the remainder is always equal to 1. That's all. Therefore the answer is 1. That's it, we're done. I'm not going to start the next one. I will see you tomorrow, okay? We'll do question number 27 for tomorrow. Tell you what, for tomorrow's problem, I'm going to actually give you homework. This is for tomorrow. This is for tomorrow. In addition to the problem that you see there, problem number 27, this is a bonus question. This is for tomorrow. This is the bonus one. We have negative 1 over 4 plus 1 over 3 plus 1 half plus 1 over 2 plus 1 over 3 plus 1 quarter. And here are the answer choices: A, B, C, D, and E. And the answer choices are 1/5, 1 quarter, 1/3, 1/2, and 2/3. Solve this problem on your own ahead of time, and then tomorrow we'll do it together. And after we finish doing this problem, we'll do the one that is in the book, which is number 27. Okay? I'll see you tomorrow. Bye now.